All right, everybody, here we go. Let's try to do the answers to this study sheet for the test. All right. Two cars in a race. One has a head start of 1.5 meters and a velocity of 2 meters per second. So we're using the formula y equals mx plus b, or xf equals vt plus xi. So one has a head start of 1.5. So that is going to be this 1.5 meters is the head start. Velocity is 2 meters per second. So it is 2t plus 1.5. The other car has a velocity of 2.15 meters per second. So it's 2.15t. And they start at the same time. So this 2t plus 1.5 equals 2.15t. So I'm going to take the 2t and say minus 2t. That gives me 0.15t equals 1.5. 1.5 divided by 0.15 is 10 seconds. That's how long it would take it to catch it. How far down the track will this occur? Well, the second car goes at 2.15 meters per second for 10 seconds. So it's going to take it 21.5 seconds to do so. Does that make sense? Sorry, my handwriting is atrocious. All right, and if this isn't clear enough, there's videos of me solving these car crash problems. Look on my YouTube. A ball is bounced from the ground. It's in the air a total of 3.25 seconds. So 3.25 divided by 2, 1.625. How fast will it hit the ground? How long is it in the air? First thing we need to know, it's only in the air for 1.625 seconds. How high does it go? xf equals 1/2 at squared. 1/2 of 9.8, because that's the acceleration due to gravity on Earth, and t squared, 1.625 squared. Squared times 4.9, 12.94 meters. 12.9 meters. How fast will it hit the ground? Well, very simply, it falls for 1.625 seconds. It is accelerating at 9.8 meters per second every one of those. So it's literally just 1.625 times 9.8. That's it. It's going to hit the ground at 16.2 meters per second for a total height of like 12.9 meters. A ball rolls off of a 7-meter high building. How long will it take to hit the ground? In other words, it falls 7 meters. That's it. So 7 meters is our xf. xf equals 1/2 a t squared. So 1/2 of that is 4.9. And then we're going to end up with 7 meters divided by 4.9 equals t squared. And then nope, we're not going to do that. We're going to find t. 7 divided by 4.9 equals square root 1.19, and we'll call that 1.2 seconds. And that's around the height of our stripe on the building, so that should sound familiar to you. Solve with only graphs. Draw clear graphs labeled with numbers. A ball rolls down a very long ramp that is not too steep. Started from the stop and accelerated at 3 meters per second for 7 seconds. The first thing we would do is we would be like this. Okay. We're going to have our velocity and our time. 1, 2, 3, 4, 5, 6, 7 seconds. Time is in seconds. And then it accelerates at 3 meters per second. So you could just go up 3 for every one of these. 3, 6, see what I'm doing? 9, 12, etc. And you're going to go up to 21. How do I know it's 21? 3 meters per second for 7 seconds. 3 times 7 is 21. So obviously I did not do what I said and draw a nice, neat graph here myself, but 21 is your height, and then you'd have a straight line. Does that make sense? 21 meters per second is your height. All right. What was its max velocity? 21 meters per second. How far did it go? All right. If we're going to make this a graph, we just shade it in. The area under the line, this is 7 by 21. 7 by 21, 1/2 base times height. I have to use my calculator for that. 7 times 21 times 0.5 equals 73.5 meters. Now it says you'll draw 2 graphs for this. Another way to do it is just like, oh, okay, here's another graph. This is acceleration. 3 meters per second. It's a steady 3 meters per second is its acceleration. And 1, 2, 3, 4, 5, 6, 7. There you go. Just make the line go straight. You know what that looks like. You shade this in. 3 by 7. A height of 3 by 7. 21. 21 meters per second is your maximum velocity. The area under the line on an acceleration over time graph is the max velocity. The area under the line on a velocity over time graph is the distance you went. Remember, these are derivatives. How far does this thing go in 6 seconds? Well, we just stop it right here. We're going to shade it in. I'm going to make this guy a rectangle. This rectangle is 3 high by 2 wide. So that's 6 meters. Now we've got a triangle right here that is 2 high by 2 wide. So 2 times 2 is 4. Half of that is 2. Everybody see what I'm doing? That's 1/2 base times height. Now I've got a little square here that's up 1 by 2. That's 2. Lord, now we've got this little triangle right here that's 1 by 1. So half of that is 0.5. And now we've got a little square here that's 1 by up 1 over 1. That's 1. So 0.5 plus 1 plus 2 plus that. You got me? 6 plus 2 is 8, 10, 11.5. 11.5 meters. All right. A skater skates at 3 meters per second. Now, we talked about this today. This is the long formula. XF equals XI plus VIT plus 1/2 AT squared. Remember, this part is what's on the hill, and this is on the flatland. All right? Skater skates at 3 meters per second for 13 seconds. So that's 39 meters is how far we've gone already. Plus, he accelerates down the decline at 1.4 meters per second. Our initial velocity was 3 when we got to the hill. We're accelerating for 2.5 seconds on the hill. So this is 3 times 2.5. This is the VI and the T. Plus 1/2 A. We're accelerating at 1.4 meters per second times T squared. Remember, we're on the hill for 2.5 seconds. 2.5 squared. So we can add these up. 3 times 2.5. 7.5, but I'll write this down. 3 times 2.5 is 7.5. 39 plus 7.5 plus 1/2. I'm going to do this on the calculator now. 2.5 squared times 1.4 times 0.5 equals 4.375. So our total distance that we did was this, 4.375 plus 7.5 plus 39. 50.875 meters or 50.9 meters probably works for me. How fast was he going when he jumped off? Okay. Now remember, we're going to the hill. When we start going down the hill, we're going 3 meters per second, right? That's our initial velocity. And then we go down the hill and we accelerate at 1.4 meters per second for 2.5 seconds. So you're going to say 1.4 times 2.5. Take my calculator. 1.4 times 2.5. This is how much speed we gained. We gained 3.5 meters per second. So 3 is what we were already going, so add those two numbers. And 6.5 meters per second is the final velocity. Last problem. A car, it's supposed to be the word car here. A car traveling at 50 meters per second will take how long to make a 2,000 meter trip? Velocity equals distance divided by time. 50 meters per second equals 2,000 meters in how much time? Just going to solve for the t. Boom, boom, switcheroo. 2,000 divided by 50. We know the answer, but I'm going to do it. It's going to take 40 seconds. Again, put units on your answers, so I don't think you mean 40 minutes or 40 hours. Hope this helps.